Our next lesson is on scatter plots. A scatter plot is basically a graph with a whole bunch of ordered pairs or points plotted on the graph. And the points have something to do with one another. For example, you might graph your height and your weight over time. Sometimes two pieces of information have correlation. Correlation is when there's a relationship between the two data values. A positive correlation is when both data values increase together. So for example, as you grow older, your shoe size also continues to increase up to a certain point. You could have negative correlation, which is as one data value increases, the other decreases. For example, as the temperature outside goes up, your heating bill goes down. That has a negative correlation. Or you could have no correlation when the two data values have no relationship to each other at all. Finally, scatter plots that do have correlation also have what's called a line of fit. And this is a line that, as best you can, goes through the center of the data values. The reason the line of fit is useful is because we can use it to make predictions about the data. So our essential question is, how do we interpret a scatter plot and use that line of fit to make predictions? First of all, we're going to take a look at correlation. Do the two data values have a relationship? We can tell based on the graph. If the points seem to be moving up, like a line with a positive slope, then they would have a positive correlation. If they seem to be moving down the graph, then they have a negative correlation. Or if they're all over the place, then they have no correlation. Our first graph, as we look at it, appears to be moving in an upward direction. So this graph has a positive correlation. We can also classify that correlation as strong, moderate, or weak, depending on how well the data values fit the line. In this case, I have several data values that are quite close to the line, but a few that aren't very close. So I would call this a moderate correlation. It's kind of like in the middle. There's definitely a relationship, but it's not perfect. And finally, we're going to interpret it. So if you look at the x value, the independent variable, the more we study, the higher our test score. Notice we're using positive words for both of these relationships. Our next graph, these points are all over the place. There doesn't really seem to be a line that I can put through the data that fits it at all. So I would say this has no correlation. And the reason for that is that how many siblings you have has absolutely no bearing on your GPA. Our last graph, we can tell that these points are going down the graph. So this is a negative correlation. Is it strong, moderate, or weak? Almost all of the points are very close to or are touching that line. So I would say this is a strong correlation. And what it means is the longer we're on medication, the fewer symptoms we experience. So notice one word is a positive word, the longer we're on the medication. The other word is a negative word, the fewer the symptoms we have. That's when we get a negative correlation. Next up, we're going to use our scatter plot to create a line of fit and write an equation for that line. So here's how we try and draw a line of fit. We try and make it go through the center of the data as best we can. We want as many points to touch the line as possible, but we also want to balance it with how many points are above the line and how many points are below the line. So let's take a look at my first attempt for a line of fit. I do have it touching a lot of data values, and I have 1, 2, 3 points that are above the line that aren't touching it, and I have about 4 points, 3 or 4 points below the line that aren't touching it. So it seems to be fairly well balanced, so I'm going to go with this line of fit. Sometimes you have to make a line of fit more than once in order to get a good one that's right through the center. I've been making line of fits for a long time, so I tend to hit a good line of fit right away. Whereas when you're first starting out, your line of fit may not be as close to the center as it should be, so you have to try again. Next, we're asked to write an equation for the line of fit. So what you want to do is try and find two data values that are right on your line. Any two data values on the line will work, and try and figure out what those ordered pairs are. It looks to me like this ordered pair is 11, 36, and my second ordered pair appears to be about 4. I'm rounding a little bit on that one, and 34. And I rounded a little bit on that one as well. The equation for your line of fit is only as good as the estimations that you're making to get those points. My ordered pairs were 4, 34, and 11, 36. To write our equation, we need our slope formula. Change in y, 36 minus 34, over change in x, 11 minus 4, gives me a slope of 2/7. Putting that into my asylum equation, we've got y equals my slope times x, putting that 4 into the asylum, making it opposite, and that plus 34 on the outside, keeping it normal. This time when we distribute, that 2/7 does not go into 4 evenly. So I went ahead and used a calculator. I multiplied 2/7 by 4, and I got about 1.14. And then I'll use a calculator again to combine my like terms. And I got plus about 32.86. Let's take a minute to talk about what the equation of this line means in relation to the scatter plot of data that we received. The slope is the rate of change in dependent over change in independent. So when we label our slope, this would be the y, the dependent, was population, and the x was year. So that's a change of about 2,000 people. Notice the y-axis was labeled in thousand every 7 years. Our y-intercept is our starting value. So in the year 2000, there were about 32,860 people in Cottage Grove. When we look at where our line crosses the y-axis, that's not a bad estimation of the starting population for Cottage Grove. Finally, we'll use that equation that we just came up with to estimate what the population will be in the year 2025. If you remember from your graph, the x-axis was labeled years after 2000. So 2025 is 25 years after 2000. So that's what we're going to substitute in for x. And again, 7 does not go into 25, so I'm just going to use a calculator to evaluate this. I'm going to multiply 2/7 by 25 first, and then I'll add that 32.86. I got almost exactly 40 for an answer. But remember, there's more than 40 people living in Cottage Grove. The population was given in thousands, so it's 40,000 people. Here's your U-Try question. Please attempt this and come to class prepared.